In this demo, I will present iWatch. iWatch is an end-to-end system that provides more intelligent surveillance. To demonstrate iWatch functionalities, we'll go through a scenario that could happen in real life. Let's say a woman reaches to our office and complains that someone was following her. The officer has this tool to investigate the woman's complaint. First, let's take a look at the components of the system. This is the map component where all data are presented. The query history keeps track of the queries we ran so far, along with some statistics. The timeline is used to narrow down the query results by setting the time range of interest and highlight specific data in that time range. The events component is the place where detected events from external agents are presented. At last, the query bar is one of the most important. It consists of two components, the dataset component and query component. Here the officer can set and retrieve specific data in specific time and place. Now let's go back to our scenario. The woman said that while she was working on the 13th of November on 32nd Street, heading to Troy Hall, she noticed that someone was following her. The officer uses the system to check if anything relevant to the following happened before. He chooses all text data. Internal incident reports correspond to reports generated by the DPS. Public incident reports are reports that are posted to the public. Tweets are posted by Twitter users. Then he completes some parameters. He sets the K value to 10, keyword to stalk, and start date the 13th of November. Then he clicks search to get the results. As you can see from the map, some data showed up. Here we can see how many were returned for each dataset selected. So let's take a look at this data. Here we have many both relevant and irrelevant data, so the officer needs to examine them. That is relevant to the 13th of November. First, the officer wants to limit the result set to smaller time range. Let's see this internal incident report. Oh, this one is not relevant to our scenario. Okay, this one seems very relevant to our scenario since the crime description was stalking, and as you can see here, the location was in a fraternity, so maybe the stalker was a member of this fraternity. So let's look some more examples. Oh, this one is also for stalking and happened also 3 days ago, so maybe in the same day the stalker was around this area. On public incident reports, we extract some derived attributes such as actor, object, or victim by data mining the text. Now let's see if tweets can help us out figure anything. As you can see here, someone states that he actually loves stalking, and we also have his profile and actual name. So maybe this is someone we need to consider. The officer needs to find out what actually happened since text data didn't reveal much. He selects the area and time of interest. And then he chooses to see the installed cameras in that location. As you can see, there are 2 cameras installed in that area, and he can choose one of them to see how is the location like. As you can see, there is movement and object recognition along with the transmission of the camera. The woman also mentioned that she changed route to check if actually the man was following her. Now the officer has the option to check if there are any captured trajectories. This is the area where she mentioned that she changed her route. So we get some trajectories. As you can see, it's on the top of the building, but if we change to satellite mode, we actually see that this was in the parking. Using the timeline, we can see the movement of the 2 people. Here we see a pin that is moving behind the other, and maybe it's the same woman. There is a point when the two pins jump at the end of the parking. This is because the parking was not in the view of the camera that generated the trajectories. Until now we have seen some text data, the real-time videos and the trajectories. The officer is now interested to check if there are any captured video at the time of interest. Here we have some stored videos at the same time that the woman reported. Those videos are stored only if they have significant movement. In the center of the screen, the blue line indicates the captured motion vector. If we check the video, we can see the woman who is the complainant. Here it appears also the man who maybe is following her. When she crosses the street, the man is also crossing the street. This is very suspicious. Here we can see another woman that she's actually recording something on her mobile phone. Let's check this also. The officer searches and finds mobile videos. Here the videos which are returned have a field of view that intersects with the rectangular area. We can view the video, its trajectory, and the field of view that is changing over time. This is our complainant, and this man seems to follow her. So we actually have video evidence for this event. Now the officer wants to know if he can find any face image of the follower. He selects face image dataset and retrieves some results. This is the woman who reported the event, and this is the picture of the follower. The woman finally entered the toy hall, and she also saw the man inside the building. The officer can now check the access control readers of the doors. He selects a circular region and places it at the location of Troy Hall. Those two readings may belong, the one to the complainant and the next one to the suspect. The officer can now use the card number to determine the owner's details. Finally, the woman said that during the same day, but later in the afternoon, saw the man in his car, driving in the 30th Street. She was able to remember only the first two letters of the license plates. The officer uses this information to check if there is a car that matches the partial license plates. There are some data beginning with the letters 5X at 9 o'clock. The suspect maybe was waiting for her.